Welcome to CW 9.5. Today we're talking about the law of cosines. So take a minute and just write down the law here. Notice how there are three versions, but the main version we're going to use is this one right here. And the main thing to note is that the back ends match. So these letters must match. So pause the video, write that down. Once you're done, unpause the video. Now a couple of things to note here. I put a few stars. We did law of sines last video. The law of sines is really good at finding acute angles. So notice how we always have to do that 180 minus trick to get all the angles. But in general, your calculator will always give you the acute angle. So it's important to think about this as we move forward today. And the other thing to know is law of cosines. That actually finds any angle. I mean, law of cosines is actually quite strong as it can find any kind of angle that you need given the right information. So let's try to do a couple things here. Here's our first question. Let's generically sketch it. A, B, C. A is 60, B is 20, C is 30. The first thing to note is we can't use law of sines because we don't have a pair. We don't have this pair, or this pair. In fact, we actually have a side angle, side triangle. In this case, you use law of cosines. So again, if you have a side angle, side, classic law of cosines problem. So I'm going to write a squared is equal to, and then b squared plus c squared minus 2, 20 times 30, cosine of 60. Now, since you have a calculator, you can just evaluate all of this. Just do the square root of this whole thing right here. But even if you didn't have a calculator, you actually could do this because, for example, this is known. We know cosine 60, so even if you didn't, you could actually calculate that. But since we do, we plug into our calculator and we get 26.46. So I'll plug that in here. Now here's the crucial next step. We have to figure out the next two angles. But what we want to do typically is use law of sines, right? That's what we love doing. Use law of sines to find, I'm gonna pause there. Some people think it doesn't matter which one you choose. It actually kind of does. What I want you to find is angle B. I don't want you to find this angle. Now the reason for that is because B is the smallest angle, or meaning it has to be smaller than angle C. So we said earlier here, law of sines finds acute angles. What I mean by that is you're going to hit some trouble if the angle you're finding is obtuse. So notice how this has the potential to be obtuse. So you don't want to mess with that. And the reason you know that is because this is the longest leg. This is the shortest leg, therefore this is the smallest angle. So you want to use law of sines to find this one. So over here, we're going to write use law of sines to find acute angles. That'll just save you a headache as you're working on your homework. So now we're going to write sine of b over 20 is equal to sine 60 over 26.46, which means b is equal to sine inverse of 20 sine 60 over 26.46, and we get 40.9 degrees from your calculator. Now, again, last class we always had to do this, 180 minus the other answer given, but this is not necessary because we know that this has to be an acute angle. So that's how we're finding the acute angle, because we have to take one that must be acute. So I should put a note on B. Must be acute. So it couldn't be obtuse, which is why, again, this step is so important. So now we can fill that in. 40.9, which means the final one must be 79.1. And we're done. Now let's go to our next one. Once again, draw it generically. Here's A, B, and C. A is 6, B is 9, C is 4. And again, this is not drawn to scale. So notice how we have all lengths here. So if you have a side, side, side triangle, that's again a law of cosines problem. Now, notice how I put law of cosines finds any angle, which means you can really pick any angle to find here. It doesn't matter. But to make it easier for you, what I want you to do is use law of cosines to find the largest angle. That way, when you hit the law of sines part, you just don't worry about it because you found the obtuse angle. So the largest angle should be B, since this is the longest leg. So let's write it out. B squared, which is 9 squared, should equal 6 squared minus 4 squared minus 2, 6, 4 cosine B. We'll just algebraically manipulate it. Cosine B, and again, don't do the math here. You have a calculator. So let's write this out. So cosine, so B should be cosine inverse of this expression. Okay, so you plug it into your calculator and you're going to get 127.2 degrees, which is obtuse, which means if you tried to use law of sines on that, it would have been an issue. So let's put that in right there. And now once you've done that, again, you can pick A or C, it doesn't matter since we know they both have to be acute. I'll pick C, and again, it doesn't matter. So I'm going to say sine of C over 4 should equal sine of 127.2 over 9. So C should be sine inverse of 4 sine 127.2 degrees over 9. And C is 20.7 degrees. And again, we don't need to check the obtuse because we know C has to be acute. And then the last angle is simply 32.1. Okay, so there's law of cosine. Notice how it's pretty easy. It's not too bad. There's a couple more examples here. Two planes leave an airport at the same time on different runways. One flies on a bearing of north 66 degrees west at 325 miles per hour. Okay, so to do this, let's just sketch a coordinate grid and label it north, west, east, south. The other plane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart would the plane be after 2 hours? So to do this, north 66 degrees west means from the north, so imagine I use a red line here. From the north, we're going to move 66 degrees to the west. So that's going to be like right about here. 66 degrees, rotating. And then south 26 degrees west, that's going to be something like this. South and then turn 26 degrees, like so. What we know is that it's traveling at 325 miles per hour. That's this one. So in 2 hours, that should be 650 miles. So I'll label that 650. And the bottom one, that should be 600 since it's 300 miles per hour. And we're looking for how far apart they are. And take a look at this part right here. If this is 66, that would mean this little piece, that's 90 minus that, so that should be 24. And then this part should be 64. So in total, that's 88. So if I move this over here, we have a nice triangle where this is 88, this is 650, this is 600, and let's call that C. And now it lines perfectly with our lesson. C squared should equal 600 squared plus 650 squared minus 2 times 600 times 650 cosine of 88 degrees. C should be the square root of all of that, and you get about 869 miles. Now for the last part, it says find the area of this triangle. So again, let's draw it generically. ABC, A is 12, B is 16, C is 24. We have no angles here. So the way you do this is called Heron's formula. You might recall this from trigonometry. It's a really nice formula. It's the square root of S times S minus A, S minus B, S minus C, where S is the semi-perimeter. Or in other words, P over 2, perimeter over 2. So to do this, we first find S. So the perimeter of this, if you add that all up, that's 52 divided by 2 is 26. Now apply the formula. We want the square root of 26. And now just do 26 minus each of the legs. So 26 minus this leg, that should be 10. And then 26 minus this leg, that is 2. And 26 minus the last leg, that is 14. And now just type that into your calculator. And then this is round to the nearest square yard. So we'll just put 85 yards squared after you type that into your calculator. And that's the lesson.